Well, thank you, Melissa, and welcome to another edition of Webinar Wednesday, where in just a short while, we will be talking with Xact Metal about innovation through metal 3D printing. Although, as we often do at the beginning of this webinar, we are going to take a circuitous route from where we are now to the topic of metal 3D printing. And we are going to start by talking about mechatronics and then about entrepreneurship. So as many of you know, we work with mechatronics programs all over the Midwest, implementing really, really cool cutting edge technology. Smart devices and smart sensors are a key part of that technology. And when we talk about smart sensors and smart devices, one of my favorite types is radio frequency identification. This isn't a coincidence. I actually started my career in manufacturing in the world of RFID. If any of you have had a loved one who was in a Alzheimer's care center, in an assisted living center, and was prone to wandering, and they put that little RFID tag on your loved one to prevent them from wandering out of a door or onto an elevator. If you have been involved with a birthing center, with the birth of a baby, where they put the little RFID tag on the baby and prevent that baby from being abducted from the hospital, that was our product. And we pioneered that market nearly a quarter century ago. It was absolutely fascinating to be part of a fast growth, high-tech company early in my career. You know, some folks even called us entrepreneurs. I don't know that we were entrepreneurs necessarily. When I was in business school, I was actually approached by the dean of the college and invited to take a class to enroll in a course on entrepreneurship. And I actually didn't do it. And part of the reason that I didn't do it was I wasn't even sure that entrepreneurship was something you could learn, as opposed to being personality traits and things that were just innate in individuals. But when we think about entrepreneurship, I think there are four things that make somebody entrepreneurial. Number one, an entrepreneur listens. When we were developing products for the healthcare industry, we did not start by going to our engineering team and saying, what do you think the market would like? Where did we start? Of course, we started by going to our customers. We went to the market and said, what would make your life better? What could we innovate that would improve your ability to do your job? And so we start with listening. We start with listening to the market and listening to what it is telling us. But we don't finish there. Entrepreneurs take another step. Entrepreneurs have vision. They take the information from the market and they make decisions about what can make the market better. First, by listening to the customers, and then by thinking about the future. One of the greatest visionaries of our generation is a gentleman by the name of Steve Jobs. As it says in this article, I actually spent my vacation recently with Steve Jobs. Well, of course, not recently. He passed away, unfortunately, a number of years ago. And I didn't really spend my vacation with Steve Jobs, but I did spend my vacation reading his biography. And it was fascinating. As you can see here, my conclusion was that he is a brilliant visionary, but then he's really weird. And then he is a jerk, and then he's a brilliant visionary again. And then he's really weird, and then he's a jerk again, and then he is a brilliant visionary. And that cycle continues throughout that entire biography. Now, the brilliant visionary part, of course, wasn't a surprise at all in this magazine column that I wrote back not long after reading his biography. Jobs envisioned and brought to market such products as the Apple II, the Macintosh, the iPod, the iPad, iPhone, iTunes, the App Store, the iCloud, Apple stores, and even digital Pixar films like Toy Story. Steve Jobs was somebody that could see opportunity where nobody else could see it. As I often like to say, if Henry Ford had asked his potential customers when he was mass producing the automobile what they wanted, they would have told him faster horses. He had the ability to listen to the market and then make decisions about what it wanted and develop products around those decisions. Steve Jobs was exactly the same way. The third thing I think makes an entrepreneur is tenacity. Lots of bad things happen in business. And as I like to say, and this isn't original, successful people are just those who stood up one more time than they fell down. Every single business, every single organization has hit on tough times. And the ones that succeed, the true entrepreneurs, are the ones that can take those setbacks and have the tenacity to push through them, to persevere, to stay on top of their game, and to ultimately reach a successful place. Finally, entrepreneurs are comfortable, at least to some degree, with risk, taking your life savings and betting it on a company, or for that matter, taking your career and throwing it away and starting an organization from scratch, or buying a company with money that you've saved over the course of time. All of these require tremendous comfort with risk. Entrepreneurs are comfortable with risk. And in some ways, those last two, tenacity and risk tolerance, go hand in hand, because the truth of the matter is entrepreneurs take risk and then have the tenacity to see their projects through to the point where that risk pays itself off. So those are the four things when I think about an entrepreneur, and I don't necessarily think of myself as one, but when I think about an entrepreneur, those are the things they do. They listen to markets, they have vision to see things that others don't, they have the tenacity and the perseverance to see their ideas to completion, and they are comfortable along the way with taking a level of risk that many of us are not. So when I think about entrepreneurs, I go back to a trip that I took late last year to State College, Pennsylvania, when I met individuals that truly meet this definition of entrepreneurship. And I welcome you today to listen in as we talk with these folks about what it means to be an entrepreneur, what it means to innovate in a brand new market. Our guests this week on Webinar Wednesday are Juan Mario Gomez and Dave Jankowski of Xact Metal. Juan Mario has an incredible background. He spent years with GE Aviation, where he took one specific business unit from zero to $750 million over that period of time. That was in the industrial testing equipment space. Incredible career. He has a bachelor's degree in aerospace engineering from Boston University. Yes, he literally is a rocket scientist. He has a master's degree in mechanical engineering from Boston University and an MBA from the University of Chicago Booth School of Business. Dave Jankowski had a great career with GE Inspection Technologies before joining Xact Metal. He has a bachelor's degree in metallurgical engineering from Lehigh University and a master's degree in materials engineering from Case Western University. Juan, Mario, and Dave, thank you so much for being with us this afternoon.
Delighted to be here.
Absolutely. So we're going to jump into our questions. We've got some great information that we're looking forward to learning from you. Juan, Mario, let's start with you. You know, I had the chance to meet Chief Technology Officer Matt Woods last year during my visit to State College, Pennsylvania. Hard to believe that was, I think, about 10 months ago. Can you tell us a little bit about how you connected with Matt and how the two of you worked together?
Yeah, sure. After I left GE, I was trying to figure out what to do next with my career, my life, and looking to either invest in companies or find a company that I would like. I had sold a lot of CT equipment into the industrial marketplace, and I was visiting the Penn State CT 3D printing labs here in State College, Pennsylvania. And in one of the sessions, I heard that there was a young person at Penn State trying to start a low-cost low-cost metal 3D printing business. And we started connecting. We went to get coffee many times, and he was asking me a lot of questions. And one day, he said, "Hey, would you like to work with us?" And I thought, "Hey, this is kind of crazy." But then I started thinking about it. Why not? Metal 3D printing is one of the areas that very excited in the marketplace. It's the area that is one of the key areas in the manufacturing world today. It's one of the key areas where engineers need to be trained in the future. And if the market is there and if we can bring lower cost printers to the marketplace, which is what it really is restricting the market from being successful and well adopted, maybe we have something here. So that's how we met. We embarked on a journey together about 3+ years, almost 4 years ago. And it's been a very fun ride.
And I know from visiting, it's just an incredible culture of entrepreneurialism at Xact Metal there in State College. And I got that sense both from you and from Matt. Tell us about what you love about leading an emerging entrepreneurial company.
It's just great. I mean, the idea that we're in State College, Pennsylvania, it's fun. It's a small university town, but it's also next to Penn State. So there's lots of talent and capabilities near us. But more importantly, just like the 3D printing business is, also our companies like that. You have people like Dave and myself that are has scars to experience in life and have done many crazy things. But there's also young people like Stevie that you see in the picture here, who are just fearless. They have great ideas. They have great motivation. They really love the technology. They love what they're doing. And they just need some guidance and direction. And then they're changing the world. And that type of culture we want to keep here within Xact Metal is one that we're young and energetic, but we also are behind our customers. We're behind what we're doing. We deliver a good product that's ready to go from the beginning, that we support it well. And that kind of dichotomy is what makes us strong, I think, and it's fun. For me, it's really enjoyable to come to the office and see, and now come online and see people and the type of ideas that we bring together.
And that spirit of innovation is alive and well, being so close to an iconic college campus, and having visited, and you toured me through not just your facility, but we spent some time on campus. We spent some time in Innovation Park. There's a different spirit in that part of the world. What can you tell us about how being located in Innovation Park affects the culture of Xact Metal?
It's great. Being here, it really brings a culture like you see in the picture. We have, when we go look for people, the people are here because they want to be here. They bring a very skilled workforce that is really trying to change the world. And if we can bring that energy and dedication to the metal 3D printing space, where people need solutions, and they need solutions that are less expensive, and they need solutions that work and do their job. If we can bring those ideas to help the industry come together, it really works. Being an innovation park, we're in the central Pennsylvania, but we're really close to a lot of areas within the East Coast and the central United States, where there's lots of technology, there's lots of innovation, lots of technology, lots of funding, and it allows us to make Xact Metal a reality. And I think that's special to us, and we like it.
And I think that was one of the things, Juan Mario, that appealed to our team as we toured your facilities, we spent some time with you, is not just the proximity to a great university, but really the understanding of the role that a company and an educator or an educational institution can play together in terms of developing opportunities and in terms of facilitating learning. I want to turn now to Dave Jankowski. Dave, I know one of your key roles is helping educators. So what makes Xact Metal's technology different from other 3D printers available to educators?
Thanks, Matt. One thing that we found is that 3D printing is super cool technology, whether it's plastic printing or metal printing. And we found a lot of students, already have a little bit of background in 3D printing, perhaps through a makerspace opportunity or something in high school. What makes Xact Metal unique is that there are certain requirements that are required to really benefit the students and the educators. Specifically, any 3D solution to be used in an educational application has to be simple to learn and simple to teach on. Number two, it really has to be modern and intuitive to engage the interest of the student. Third, you have to have fast turnaround between builds, so it will maximize the number of students who can actually use it to print their parts. And then also, as important, it has to be accessible and affordable to match the budgets of the educational departments. We feel with our unique technology, the XM200C meets these requirements. It is modern, intuitive, and just very simple to use. For young people and even for older students that will quickly pick up the operation and the principles behind it. The unique design allows a large, easy to access build chamber. As you can see in the picture behind me, that will enable these fast turnarounds, which is just so critical to really maximize the use of the printer. And with an affordable price, it really meets the budgets of even smaller educational departments.
So simple, modern, fast, and affordable. That's really, in a lot of ways, what's going to appeal to educators. And then the next question that they always have, and certainly a question that we always have for people, is it's one thing to have awesome technology and be able to build really cool parts and kind of see the jaws drop and the eyes pop wide open. But equally as important, if not maybe even more important, is what are the students learning as they're going through that process of experiencing the technology. So touch a little bit on what competencies our educators are able to teach using Xact Metal.
Yep, it really covers the across the board in 3D printing opportunities and technology. They learn the general background, the general theory behind additive manufacturing, which complements the more traditional subtractive manufacturing processes such as machining. designing for additive, it really isn't that hard, but it is just different. So the different techniques that are used, again, when compared to these traditional techniques, it enables new design capabilities. There are parts that are significantly easier to produce using additive technology than with more traditional methods. And then, of course, being able to develop a background on how to design for additive, and then how to print the actual parts with metal additive technology.
Fantastic. And we're going to turn now back for one last question before we head into a product demo. And this is going to be a question for Juan Mario. I know that we have viewers on with us today that are from industry, high school, technical college. I know we have a tremendous number of university instructors, professors, program directors, deans, and so on that have registered for today's webinar. For those people in particular, Juan Mario, how are universities using your technology to develop new products and to build engineering skills for their students?
Yeah, it's a great question. And it's a complex answer, but in reality, you can put it down in two points. One is one of the main reasons that metal 3D printing has not been adopted today is the price. The systems have been traditionally too expensive, and we're doing our job to make that more affordable and make it affordable so you can bring it into a school, you can have access, the students can have access to the machine and so forth. The second part is just the students. This is the next generation Industry 4.0. This is the next technology that people want to have in their factories. We are bringing this technology down to every manufacturing facility in the United States, not just the rich, super rich companies, quote unquote, but really the small, medium enterprises. And by being able to bring this technology to educators like yourselves, it really is creating the next generation engineers, the next generation technicians, the next generation scientists, and giving the ability to be there. When we do, we hire people, of course, for our company, and when we go interview for people, and the line is 10 times more at our booth than any other booth at the show, because we have 3D printing technology in our portfolio of things. When the people that work with us as interns and summer hires and so forth, they get a job immediately. They're sought out because people want these skills. And all we're trying to do is make this more affordable so that more and more people can use it. But we need your help to also have it in your places, so we can have the technicians and the engineers and the scientists that can run this technology and take it to the next level.
Fantastic. And just great answers to the questions that we've had for both of you today, Juan Mario and for Dave. So thank you so much for the articulate answers. Now is for probably, I don't know about the most exciting, because you have been fantastic guests, but I know a part of this presentation that our audience has really been looking for. We are going to go now to State College, Pennsylvania, to your lab, and we are going to see your technology in action. So to the two of you, thanks so much for being with us, and over to the lab in State College, Pennsylvania.
Thanks for having us.
Thanks, Matt. What Stevie Feltman, our application expert, and I are going to be doing over the next 10 minutes is walking through the operation of our XM200C metal powder bed fusion printer. Before I hand it off to Stevie, let me just quickly walk through with a series of slides what you're going to be seeing. The first step is preparation of the build file. Essentially taking a supplied CAD file, running it through some software to optimize the position of the part and the orientation of the part on the build plate. The second step, we're essentially loading powder into the printer. The printer operates by using a high-powered laser to outline the shape of the part. It fuses the powder, and when the powder solidifies, it assumes the final shape of the component. As you can see, Stevie is wearing some personal protective gear that is required when you have the lid of the printer open and you're adding powder. Once the lid is closed, the PPE is no longer required until you reopen the lid to remove the part. During the virtual demonstration, to make it easy to understand, we will not be actually using real live powder, so Stevie will not be using the PPE. After loading the printer with the powder, a couple other steps to prepare the printer to print the part. We close the lid, we purge the machine with an inert gas such as nitrogen or argon. Stevie uploads the build file.
via USB or through a Ethernet connection. We level the build plate, and then the print is actually conducted. After the print is done, we unpack the print. As you can see on the bottom left, you can see the parts, and on the right, the powder is being removed. After the build plate is removed, we have to cut off the part from the build plate. Metal powder bed fusion printing is a micro welding process. So the part is actually welded to the build plate. In this case, you can use an EDM, a precision bandsaw, or even a flush cutting tool to remove the part. So at this point, I'm going to turn it over to Stevie. As I mentioned, Stevie's been with us for about 2 years. She is very passionate about 3D printing. So I'm going to turn it over to Stevie.
Let me go ahead and share my screen. Like Dave said, the first step in creating a print for the XM200C is loading a file into our software. We have partnerships with both Materialized Magics and Autodesk NetFab. Here I have open Magics. We have a scene created for our printer, illustrated up here, the XM200. And so when you have a scene, it opens up a build area that is representational of our build chamber in the printer. Here we're able to import STL files using the import part command. And this blue mass is a support material that is applied to the part as well. When your parts are all done getting set up, we can export the part. Up here on the XM200 tab, we can select build. And we can rename the file. And submit it for a quick export. You can see a notification has popped up that our print is now being sliced. This is our XM200C. As you can see right inside, everything is very simple and easy to see. We've got our feed cylinder. This is the chamber where the powder will go, and our build cylinder. This is the chamber where the print will occur. Between each layer, the feed cylinder will raise and the build cylinder will descend, and our recoder will travel back and forth between the print area to add more powder from the feed cylinder onto the build cylinder. We also have two manifolds. This is our high pressure manifold, and this is our low pressure manifold. The high pressure manifold has two bolts that keep it bolted down, and the low pressure manifold lets out for easy cleaning. Over here is our catch bin. As excess powder is being brought across the build area, it'll fall into a funnel. This will then end up in a catch bin that can all be resieved and returned to the printer for the next print. This is our optical window. As you can see, back here is where the scanner is. So the laser comes in and gets reflected off of a few sets of mirrors on an X and Y gantry. And these move 500 millimeters per second to expose the layer over the print. Here we have the thumb drive with our print that we exported. To upload it, we simply put the USB inside the printer, and then a notification screen will pop up. Using this, we can upload our build, and here it is, test parts. You can even upload prints while the printer is already running. So for this next portion, to simulate starting a print, we can add a build plate. So let me grab one. So here's a build plate. These are made of A2 tool steel, and we reuse them between prints. We simply drop it in and use a 3 millimeter hex key and 4 screws to bolt it down. Great. So now we have our build plate installed. Before starting a print, we would descend the build plate so that it is flush with the lid of the chamber. This is so that the recoder has clearance to move to start the print. Great. Now we can add our powder. Like Dave mentioned, we won't be using live powder, but our powder arrives in these bottles from Praxair. So we would simply unscrew the top of the lid and pour the powder directly into the printer. After it's loaded, we use a scraper to wedge the powder to expose any dormant oxygen pockets. So to start the printer, all we'll need to do is close the lid, engage the latches on either side, and then we can begin the auto purge. As you can see on this printer that's running, we have a green light. That's because these LEDs are status indicating. The blue light on the previous printer indicated that the printer was in an idle state, whereas the green indicates that the printer is running and in a printing state. Here you can see on the front that the printer is actually printing. The display is enlarged. This shows that the laser is emitting over the part and the decoder is bringing across more powder between layers. We also have some information on display here at the top. Here you can also see that the feed and build cylinder positions are locked during the print, so no one can come in and change the positions during the print. But you can change the charge rate, which is the ratio of powder that's brought across between prints. Over here we have the data tab. This gives some quick information like the oxygen level and also different pressures inside the printer. This can help to know when the filter needs replaced. Here on the build tab, we can see builds previously uploaded to the printer, and we can also see the build history. These are all prints that have currently been run. One of my favorite features about the printer is the detailed build log. Whenever the printer runs, it actually takes a picture pre and post laser exposure for every layer and also takes a data sample every second. All of this information is compiled into a zip folder that you can then reference after the print. So if you come in the morning and the print doesn't look exactly how you thought it would, you can quickly reference the build log and see if something happened during the print, like insufficient supports being used or your argon supply running out. Now we're ready to begin removing a part from the XM200C. First, we'll begin by undoing the latches and lifting the lid of the printer. Typically, we would see powder across the feed and build cylinder. Our first step would be to take all of the powder in the build cylinder and move it into the catch bin. You can do that by using a brush to manually move it across, or by using a vacuum and cyclone separator to vacuum out all of the powder and put that through a sieve. All of the powder in the catch bin and build cylinder can be re-sieved and returned to the printer to be reused in the next print. Once all the powder would be removed, we can then eject our build and remove it from the printer. So here we have our print. Once the part is removed from the build plate, additional post-processing steps can include removing support material from the part, feed blasting, or even heat treatment. So with that, that concludes our XM200C virtual demo. We want to give a big thank you to Lab Midwest. Back to you, Matt.
Well, thank you, Stevie. What a great demonstration of cutting edge technology. We learned so much, and I really appreciate you sharing that with our audience. We are going to wrap up Webinar Wednesday for this week. My thanks to our guests, Juan Mario Gomez, who's the CEO of Xact Metal, our friend Dave Jankowski, who is the commercial sales leader for Xact Metal, and finally, Stevie Feltman, for just that phenomenal presentation of really, really great technology. Thanks so much for being with us. We hope you'll join us next week.